Thank you very much, Petro, and thank you for setting up this hybrid version of the seminar series. Much appreciated. It's my great pleasure to introduce to all of you Robert Lindsay, or Robbie. Robbie got his PhD at Oxford in England in theoretical nuclear physics, where he happened to have met somebody we know quite well, David Sinclair, and has met other people in board with Snow. And as Robbie was very busy when he went back to South Africa, focusing on solving problems in the nucleus, somebody approached him and suggested that maybe you should also worry about radon, particularly in mines. And that's how our paths have crossed. Because you may have guessed from the title of Robbie's talk, there is a bit of an introductory part to it. I should pass the floor on to Robbie, and thank you, Robbie, for giving this seminar to us.
Okay, thank you, Jacques, and thank you, Peter, for setting this up. This is a sort of new one for me to be giving a talk on Zoom where people are listening from all over the place. I've been Zooming a lot in the last year or two, of course, but usually it's just been local things. And especially thanks to you, Jacques, for hosting me here at Snow Lab. So this is going to be a slightly non-standard physics talk. There's not going to be all that much about equations and stuff like that. It's really just going to be how I ended up being here today, which is a weird story because, 5 years ago, I'd never thought I'd be working on neutrinos and visiting Snow Lab. Okay, I hope I won't bore you too much with some of the stories about South Africa and how I got to be here, but hopefully it will be interesting. And at some stage, I will talk a little bit about radon and thoron that we've been measuring in a mine recently, which is the opposite of what you're doing here at Snow Lab, because I had lots and lots of thoron. The problem was not that we had too little. Okay, I hope some of it will be interesting and that it won't take too long, because somehow when I get talking about these things, I get quite excited about some of the things that has been happening in South Africa and at the University of the Western Cape that I'm at. Okay, all of that should become clear as we go on. Right, if you want to know the outline of my talk, I'm just going to say something about South Africa and then the science that we do there, and something about the University of the Western Cape that I'm at. It's quite an interesting history of the relatively new university. It's not much older. It's about the same age as Laurentian. It started in 1960. And then I'll say something about neutrinos. There's a history of neutrino measurements in South Africa, actually, but then it quietened down, and we're thinking maybe it should open up again, which is why I'm quite interested in what happens here at Snow Lab. Then I will say a bit about radon, because there's quite a bit happening in South Africa. And then I will say something about what the future might hold. It's got lots of question marks, because certainly, as I say, 5 years ago, I didn't think I would be here giving a seminar at Snow Lab. Right, when you come from the other, pretty much the total opposite side of the world, one should maybe just say where we're from. I gave a talk in the US a couple of weeks ago where I showed the same map, and I then explained where we were. And I said, I know the US, the people from the US, according to all the stories, their geography is terrible, but I'm sure the Canadians are better. But just to remind you, South Africa is actually a country on the southern tip of Africa. It's not just a regional description. When we talk about North Africa, we mean Morocco, Algeria, those countries, and West Africa, the ones over here. Southern Africa is sometimes used to describe all the countries there, but South Africa is a specific country. Okay, just in more detail, we have 9 provinces. If you've never been there, you should come and visit us. The the places that I will be referring to are Cape Town, which is where the University of the Western Cape is. I seem to have lost my mouse, but it doesn't matter. Cape Town at the bottom there. And then Johannesburg is the biggest city in South Africa, up in Gauteng province. There we go. Johannesburg, that's where the gold mine is, gold mines are. And Johannesburg was pretty much built on gold mines, I guess in the same way that Sudbury has been built on copper mines and nickel mines. Before gold was discovered in Johannesburg, there was absolutely nothing there. And that was in 1886, if I remember correctly. And subsequently, it's grown to one of the biggest cities in Africa. Okay, the University of the Western Cape that I'm at, as you might guess, is down in Cape Town. It's not by any means the biggest or the oldest university. There is a University of Cape Town, and we get very upset when people confuse UWC, University of the Western Cape, with the University of Cape Town. Well, some people get upset. I don't mind too much because they're the old university who think they're the best, but I think we're giving them a good go, as I will explain later. Okay, so South African history, some of you might have heard of apartheid, of course. That was big news. Some of the younger people might luckily not have heard about it. We're pretty sure that mankind started, or humankind started in Africa. Lots of people think it was actually in South Africa, but we're not sure about that. The original groups have all been sort of moved around and whatever. There are many different tribes in South Africa speaking different languages, as I'll mention as well. What happened then was like Canada, we got some Europeans coming. There was a Dutch settlement. The Dutch settlement in 1652, which was important for their links to the east. People had to get fresh vegetables. And then the British took us over in 1805. And since then, part of the history was a bit like that of Canada. We had sort of semi-autonomous states and so on. The big developments in South Africa was, though, the discovery of diamonds and the discovery of gold, which eventually led to the Boer War, when the British fought against the local two, what had been independent Dutch-speaking provinces, the Transvaal and the Free State. Anyway, then we became a union, and in 1948, the Nationalist Party came to power, and apartheid, which tried to separate the races, very weird history. At that time, it didn't seem so strange because, you know, at that time, Britain still dominated, or still, India was still a colony of England. Anyway, that was not such a good story, but there were a number of places when there was then uprisings against this weird system. Sharpeville is a well-known one, Soweto uprising. I'm old enough to remember that in 1966. And after that, it was clear that South Africa had to change. I went to study in the UK, and then I returned in the 1980s. And at that time, there were states of emergency in South Africa, detentions and whatever. A lot of talk of terrorism, but a lot of talk of freedom fighters as well. And then in 1990, the white government decided that, well, they had had enough, but that there was no way that they could go forward. And South Africa was struggling economically and so on. And then in 1994, we had our first democratic elections, which the ANC, the African National Congress, won quite easily. And Nelson Mandela became the president after he had spent 27 years in jail in and around Cape Town. So what's happened since 1994? We have a new constitution, new everything, and President Mandela rightly is looked at around the world as an amazingly reconciliatory figure. He was not a hands-on president, but he tried to keep everybody happy, and he had an amazing aura, which certainly started the country off in a new way. And there was a lot of feeling of optimism. Some of that optimism has gone away, but there is still a feeling that we really dodged the bullet, that the country could have gone into a civil war. I won't go into all the details. Thabo Mbeki was the second president. He was the guy who really made sure that the country changed. They had to change all the old discriminatory rules and laws. They spent quite a lot of money on upgrading township areas, more water, more electricity, and so on. And what was interesting too is under the ANC had quite a lot of support from the old USSR. And so there was a very strong group, a socialist group in the ANC, and there still is. However, Mbeki changed things and moved more towards a Western capitalist free market system, which is pretty much what we've got. However, there are various rules on trying to change the economy. There's still a lot of inequality. We'll certainly emphasize that as we go on as well. Okay, so what's the state of the country? We have 11 official languages. We have 9 provinces, 11 official languages. So there are different people speaking different languages. I have a student here with me who speaks Xhosa, which is one of those languages with a click in it, only found in Africa. And not easy for us who didn't grow up speaking that language, of course. 9 provinces, but not like in Canada, not much independence of the different states. And we have about 60 million people, still growing a lot. However, the birth rate has tapered off and will not grow too much more. However, because South Africa is successful and some of the other Southern African countries like Zimbabwe are struggling, we tend to have a lot of refugees as well. Okay, so there's good news. We have freedom. We have a liberal constitution. We don't have the death penalty. I'm sorry, some of this was a bit aimed at the American audience, I guess. We have abortion rights, equality between the sexes. And it's quite interesting. I mean, traditionally, most of the tribal groups in South Africa had quite a patriarchal society. However, now the ANC is trying very hard to have 50% women MPs, and we're close to that. There was a lot of corruption, but that's been tackled, and our previous president has actually been charged with corruption. But it's not all good news. There's bad news as well. The economy is not doing too well. We depend very much on resources, selling our gold and platinum and whatever. Unfortunately, we're still very much a resource-based community, country, and we have to import things like oil. We've got no oil. So we end up not doing well when the oil price goes up and so on. So we depend on the commodity cycles, like I guess Canada and Australia does to some extent. Okay, unemployment is large, crime is bad, the murder rate is high, and serious crime is not good. There's still a lot of corruption. Any new government or any new country where the police changes and so on, one tends to, some things work well, but some things do not work well. And when you change things, it goes downhill quite often. Anyhow, however, there are lots of challenges, but there are also lots of opportunities. Inequality is unfortunately still one of the worst in the world. So we have a black government, but they're trying their best to uplift the poor and reduce unemployment, but they are really struggling. Some problems we have right now as well is we have an electricity shortage. Some of the old coal power stations are beginning to break down. The good news is, however, that South Africa has a lot of opportunities for solar power. So we are at a crossroads there. If we can get the solar power running, and if we could get batteries, which would give us the power when we need it at 9 o'clock in the evening or 7 to 9 in the evening, then we would be fine. But it's going to be quite a battle before we get there. Again, lots of challenges, but lots of opportunities. Okay, just a picture to sort of tell you how things are going in South Africa. Lots of people are poor. Here you see an old Volkswagen Rabbit, I think they were called in the US, and if they were in Canada, they're probably called the same. They were still made in South Africa for a long time and sold. This one, as you can see, looks pretty old. It's got a couple of bumps on it and so on. The traffic light in the background, you will see, is not working because there's a power outage. This was just on my way home a couple of weeks ago. That's the same traffic light, not working. The good thing about South Africa is the cost of living is just totally different to what it is in North America. So, I mean, my salary is such that I'm sure I couldn't buy a house in Sudbury, certainly not in California, in Palo Alto, where I was last week. On the other hand, here's a guy selling oranges next to the road, and I bought a pocket of that, about, I don't know, 20 oranges for about $1. Whereas I see oranges in the US, I saw one orange for $1. So that's not quite the exchange rate, but that's the sort of thing that you find, that we live on a totally different economic scale. Okay, let me move on from, well, just one more on inequality. We have, therefore, in Cape Town, here's one of the big shopping centers with marble floors and all the rest, all the good things that the rich can afford. On the other hand, in Cape Town as well, you will find a shanty town like this with people living in tin shacks. In Cape Town, they're building a lot of new houses. You can see Table Mountain in the background. There are a lot of new houses being built, but because there are other poorer areas of the country, like the Eastern Cape, where the student with me comes from, there are always people coming to Cape Town in the hope of finding a job. So again, lots of inequalities, lots of challenges. Right, so what does one do in a country like that as regards science? Let's get back to things that you're all scientists are all interested in. That's quite an interesting question. What does a terrorist group, if you called them that before, or a bunch of freedom fighters when they come to power, what do you think they should do for science? Scientists, some of the more negative ones of my friends, were saying, well, no, this group, they're going to spend all the money on primary schools and high schools, because that clearly is where there's a big backlog and so on. And science is not going to be important. We all know the arguments that if you're an industrial country, if you want to do well in the world today, intellectual property is important. You must come up with new science and new ideas. And slightly to my surprise, the ANC actually bought into that. There were a couple of really visionary people who said that for South Africa to get out of this grip of just being dependent on what's the price of platinum in the world and just exporting our raw materials, which eventually will run out, as gold is already doing. South Africa used to be the biggest gold producer in the world by far, and now we're something like number 10, because a lot of the old gold mines are running out of gold, and several of them have shut down. And that, of course, is an opportunity, which I will mention a little later on, that gives us an opportunity for perhaps having an underground laboratory, such as Snow Lab in one of these mines. So what the ANC did was they first looked at a couple of examples where we have an advantage in South Africa because of our geography, where we could attract people, where we could attract scientists or the world to come to us. The first one was the SALT telescope, which is one of the largest optical telescopes in the world, which was built partly with American money in a place called Sutherland, which is about 300 kilometers from Cape Town up in the mountains. And it is evidently a pretty good place for watching things. It's one of these telescopes based on different mirrors which work together. It's based on one which is in Texas. I forget what it's called, Hobberley, something or other, the one in Texas, and ours is a bit of a copy of that. I won't go into the PBMR. The other important one, in 2007, South Africa decided that they had to put in a serious bid for the square kilometer array. That's a European project trying to build the largest, or not trying to, they are building the largest radio telescope in the world. And when South Africa got involved, we just put in a bid because they had to find some place in the world to build this telescope. And it has to be, there are lots of characteristics that you need. You need to be in an area where there are no cell phone towers. That already eliminates a large part of the world at this stage. So it had to be radio quiet and a number of other things, huge areas needed for it. Eventually, all the dishes will add up to an area of a square kilometer. But some of the dishes will be in other parts of Africa as well. And there's also a certain part of it being built in Australia. But so this is a really huge project, 1.9 billion euros. It's already being built. It's sort of halfway, as I say, mainly European money coming into South Africa. But again, I think there was quite a lot of foresight in South Africa. They said that this mustn't just be a project for the Europeans that come to South Africa. The locals must be involved as well. And therefore, a university like UWC that I'm at, we decided to start an astronomy department. And now we have probably half the staff in the department are linked to astronomy in some sort of way. I won't go into the rest. South Africa also started several other research projects in the last few years, which shows that they're interested in. Just some nice pics. There's a picture of one of the dishes being transported out into the Karoo, the flat area in the middle of South Africa where this is being built. And there's a picture of one of the radio telescopes. I thought actually that this was a real one because there are ones like this now already standing, but they have lots of, the astronomers have lots of money for making nice pictures. And if I look at this again, it looks like a drawing, not like a real telescope. But they are up and running. The first part of it is called the Meerkat radio telescope, which was built mainly with South African money, which sort of started and showed our commitment towards this project. And they are up and running and already taking radio images, looking at the Milky Way and various things like that. So I have quite a lot of astronomers in the department with me. Okay, let me get to the University of the Western Cape, which is where I'm a lecturer. Under apartheid, we had a terrible history of universities that were being formed for separate languages. South Africa now, English is the sort of language which is the language of science and the language of business and so on. However, under apartheid, there was a feeling, well, there had to be languages, universities for Afrikaans speakers, and then there was this ridiculous idea of having universities for separate races. I wouldn't want to talk too much about that because all I can say is we are red-faced if we think back of those days. So I joined the University of the Western Cape in the 1980s. That was one of these universities which was not started for so-called white students. It was supposed to be mainly for colored students. I won't go into all that history, but when I joined, the university had very, very little science, very small science departments. The idea was we would train teachers. There was not really much for research. There was a lot more activity on the humanities side because in the political science department and those departments, the history department, they were heavily involved in the anti-apartheid struggles. And we had a lot of clashes at the top there. The photograph, I don't know why it's in black and white because it's not so old. There's a bunch of the leaders of the university and a lot of students, but this is not a graduation ceremony, as you might guess. People are wearing their gowns. The idea was to walk to the gate and to have a placard demonstration against the politics of the day. And then what would sooner or later happen in the bottom picture is the police would start shooting with rubber bullets and tear gas, lots and lots of tear gas. And this is a famous picture because it was on one of the newspapers of the one deputy president, shall we call him, of the university, who walked towards the police saying, please just let us have a placard demonstration and keep it peaceful. There's no reason for rubber bullets. But I'm told that soon after the picture was taken, he turned around and ran away as well. Anyway, so that was where the university was at the time. Subsequently, the university has grown and a lot. The new government was sort of trying to get universities like that work on a better level, and there was quite a bit spent on the science faculty as well. The other famous person linked to UWC is Archbishop Desmond Tutu, who I think was a pretty amazing guy. He was the chancellor of the university, which is a sort of just a title. He would then come and hand out the degrees. So he was the he was the chancellor. Oh, that's actually a mistake. He was the chancellor from 1987 to 2012. He passed away. So since 2000, the university has been growing a lot. So this is what we looked like in the 1980s, sorry, when I joined there. There's not much that's important on this, just a piece of random trivia. The person there is on the top right hand side is a colleague of mine who later went to Sweden and is a professor there. He's a guy, Cedric Linda, who went to Pretoria Boys High School in Pretoria in South Africa, which is a normal high school. That high school is now often, when it's mentioned in South Africa, is mentioned because one of its alumni is somebody who has Canadian links and who was born in South Africa, but then came to Canada and now is, by some accounts, the richest man in the world, namely Elon Musk. I'm not sure if he's famous or infamous. I think the jury is still out on that one. Anyway, right, so physics at UWC. So I joined the department, sorry, there's too much on this slide. By 1997, we published 5 papers that year, and we had about 6 or 7 postgrad students. That was 1997. But in 2002, we joined forces with the University of Zululand, which had lots of students who couldn't really do postgraduate work there. That increased our postgraduate numbers. We increased our links with groups in South Africa. And in 2010, we joined the Square Kilometre Array project, and things have just boomed. So that now in the headline at the bottom, last year, I think we published about 70 papers, several of them astronomy papers and so on. And we have over 60 postgraduate students, masters and PhD students in the department. So our physics department has done exceptionally well and grown enormously. And it's always difficult to say what numbers mean. However, if you grow by a factor of 10, I guess it's clear that we are doing something right, shall we say. And physics in South Africa has been hugely transformed. I mean, when I went to the South African Institute of Physics conference in the 1980s, there were a few black faces, whereas now it is well above 50% black. I haven't counted how many females are there. Females are often a problem, as you know, in physics. Okay, let me get to some more detail where here's just one of our groups of postgrad students. Right, so let's get closer to me. My interaction with neutrinos, as Jacques mentioned, I did my DPhil, as they call it there, at Oxford University. And when I was there, I worked in well, nuclear physics, but low energy nuclear scattering. I wasn't working in particle physics. There was one big neutrino story while I was there. The second bullet. Keep losing my mouse. There we go. There was a group in the Soviet Union, the ITEP group, who some of you have to be quite a bit older to know about this. They came up with a measurement and said the mass of the neutrino is 30 electron volts. And that caused a lot of excitement in the department. Yeah, a lot of skepticism at Oxford. I think most people said, well, this seems a little bit unlikely. And a lot of people went working away very soon to try and figure out what these bunch of serious Soviet Union researchers were doing wrong. And eventually they found what was happening. Two of the people there that were working on nuclear scattering, nothing to do with neutrinos or whatever at the time, were, as Jacques mentioned, David Sinclair, who I met a few times, and then Nick Gilly. I chatted to him quite a bit through various personal connections. And both of them then got involved in Snow Lab because the accelerator at Oxford shut down soon after that. And David Sinclair, actually, he had a permanent job at Oxford, but left and came back to South Africa. And Nick Gilly also then worked on Snow. Okay, what about South Africa? Well, it turns out that Frederick Rhines, the guy who won the Nobel Prize for measuring the neutrinos first at a reactor, he got involved through a personal connection with somebody in South Africa, and they said, well, can't we measure in a gold mine where we can get rid of the cosmic ray background? Exactly the same reason why you used snow as well. Okay, and then I'll get back to 1998 when I started working on radon. But let's first go to the Rhines experiment in a gold mine. This I stole from, this slide I stole from a lecturer at Witwatersrand University, Elias Sidros Haddad. I did mention that somewhere. There we go. Anyhow, this was done at the East Rand proprietary mine in Gauteng, which is close to Johannesburg, in the early 1960s. So this is a long time ago by these standards. Again, it was a shaft that wasn't being used very much, and they had enormous problems. Of course, at the time, there was no other laboratory even close to that in South Africa. So they had all the usual problems of getting cables and scintillating liquid and photomultiplier tubes and whatever down there. And the experiment was done more than 3 kilometers underground, as you can see there. Getting down there, the lifts weren't, the elevators weren't that good. It took more than an hour, according to what I've heard. Anyhow, this is long before my time, of course, and afterwards there was a lot of talk about doing something like that, but it never really was taken forward. Okay, and this the experiment was successful. Here's a publication in Physical Review Letters in 1965, with Rhines as the first author, and Friedel Schellschop, a famous, well, one of the first South African physicists who really did a lot of research, eventually became vice president of the University of the Witwatersrand. So they are the two guys who were in, well, there were two South African guys involved in this as well. So since then, of course, people like me have always said, well, we still have the gold mines and there's still nothing happening in it. And neutrinos have become more of a thing to do, right? Firstly, people, well, it was so difficult to measure neutrinos, people said, well, we can't do too much about it, can't measure them too easily. But of course, now SNOW has shown that things can be done. I had a Dutch collaborator who I worked with quite a lot. His idea was we could study the Earth as well with geoneutrinos, a field which is now being talked about more and more as well. And various neutrino measurements have tried to sort of put limits on how much radioactivity is in the Earth. Of course, we don't know too much about what is at the center of the Earth. Everything there just consists of models. And if we can measure anything which will tell us something about that, it will be useful. Okay, so because of that, as I said, I was quite interested, and a number of us in South Africa have been talking about underground labs. And what always people have told us is, well, you better get involved with some group that are working underground. It's very difficult to start from scratch. Okay, so when the nEXO idea came around, when one of my colleagues spoke to a visitor from the US, Giorgio Gratta, we immediately said, oh, that sounds like something to do. Okay, right, I'll say something a bit more about that. Okay, can South Africa house an underground lab? Well, I don't think it's going to happen overnight, but because of that history, and we've been speaking about it, I think there is a possibility that something like that could happen in the future if neutrinos keep growing and there's more and more interest for having labs looking at neutrinos. And of course, then dark matter is the other reason for having underground labs at the moment. Clearly, we won't have enough money or want to or be able to do something like that in South Africa all by ourselves. It would have to be some international collaboration that's studying either neutrinos or dark matter and need a venue. And of course, as I've seen just in my 2 days that I've been at Snow Lab, is one needs a lot of infrastructure above ground as well to have anything like that happening. Yeah, there was even a talk given by one of the well-known physicists in South Africa, Zebulon Vilakazi, who's now actually, like so many good physicists, has moved out into administration, and he's the president of Witwatersrand University, which is one of the biggest universities in the country. But he is a high-energy physicist by training. He's still involved at CERN. So he gave a talk a few years ago mentioning a few people that were involved or interested in an underground mine. But to be honest, this is pretty much a virtual collaboration. There's nothing really happening down on the ground. Okay, another thing which made me think about underground workings is close to Cape Town. This is about 30 kilometers away, so I could drive there quite easily and set up an experiment and drive back again, which is what I've done, is a road tunnel, the Huguenot Tunnel. It's through the mountains near Paarl in close to Cape Town. It's a road tunnel and it's not that deep, so it would not be, I think, suitable. We have tried to do some background measurements, but we need to do more. I don't think it'll be suitable for an underground lab, but there is a lot of reduction of the neon flux, of course, down there. And there are 2 tunnels. The one is where the road is running. The other tunnel is at the moment not used at all. It will be used as a road tunnel as well. At the moment, you drive in both directions in the one tunnel, but it is getting close to its full capacity. And so at some stage, they will be using the other tunnel as well. So at the moment, we can work there, but what we would like to do is blast a bit of a cavern there off the one side where we could test things. This would be very close to Cape Town, and you could go and test equipment or put an HPGE there where you don't want to have too much background and things like that. So that's an opportunity which is there. Huguenot, for those who know their history, the French Huguenots came to South Africa, not very many, but enough to influence the population quite a lot, because this was in the 1680s, I think, when there was the religious war in Europe or in France. And the Protestants fled in fairly big numbers, and some of them came to South Africa and settled close to where this tunnel is, which is how the tunnel got its name. Okay, then just back to my history. I then, as Jacques said, about a bit more than 20 years ago, a guy walked into my office and he said, "Do you know anything about radon?" And I said, "No." And he said, "South Africa is the radon capital of the world, and you didn't know about it, and you're a nuclear physicist." And I said, "Yes." And so he then explained that actually, even though by then radon was, of course, well known as a problem in places like in the US and so on, and people were measuring it in houses. In South Africa, it's not such a big problem in houses because we have a fairly mild climate. I'd never seen snow until I went to England. So, and it's not all hot. It's not that hot. I mean, in my house, I didn't have an air conditioner until a few years ago. It doesn't get that hot in summer either. So it's very mild. So people tend to have windows open and the ventilation is therefore very good. So even though there's quite a bit of radium in the ground in many parts of the country, there's not such a problem with radon in houses. Anyhow, however, this is different to the gold mines. In the gold mines, of course, you are underground. They're very deep underground. There's ventilation, but it cannot get rid of all the radon. And what's particularly makes it difficult is there are a number of, mostly, not always, but mostly the gold mines have quite a lot of uranium in them as well. Uranium and gold tend to go together. Not always. Some of the mines do not have much uranium. Those are presumably the ones we would want to choose to have an underground lab in. but some of them do have high values of uranium and therefore radon. And that means that the gold miners are actually exposed to quite a lot of radon. And in the 1990s already, it was decided that a lot of the gold miners had to wear monitors. They just wear these alpha track devices, which is a piece of plastic which is sensitive to alphas. So the alphas make a track on the plastic, the polymer. And when you then etch it, it makes a line which you can see under a microscope. So there are actually about 10,000 miners that in South Africa, well, we have a huge number of underground miners in the gold mines and platinum as well. In total, in South Africa, I think there are about 100,000 underground miners. By comparison, I think Canada, which has a lot of mining, has in the uranium mines, there are a few thousand in the uranium mines. So we are on a different scale. And as I say, about 10,000 miners wear these monitors. The others don't wear monitors because the areas have been measured and they think, well, it's not really high enough. In the areas where people wear monitors, they are classed as radiation workers because the radiation is so high. And yes, so and therefore, well, and many of them get above 20 millisieverts per year, which, as you might know, is the limit for, well, it's a bit more complicated, but you mustn't average above 20 millisieverts a year. Anyway, so I then said, yes, this is an interesting thing. If it's that important, then I better get involved. This guy actually wanted me to test some detectors because he wanted to use different detectors. So immediately I was more interested in detectors and how do you measure radon, how do you measure thoron, rather than in radiation protection. But I did get involved in a number of radiation protection issues. On the left here is a picture in Paarl. This is close to where the Huguenot Tunnel is, but on the other side of the valley, the one side of the valley is where the tunnel is, and I don't think there's much radon there. On the other side of the valley is a granite outcrop. And in those houses, we measured the 200 becquerels per cubic meter for those who are interested in those sort of things. In several of the houses which had wooden floors and so on. So as I sometimes say, when I show this picture, there we are going into the basement, looking for the radon on the left. On the right is an old church, which has quite high radon levels as well. Again, it has a wooden floor with big gaps between the different floorboards. In a sense, it was built like that so that the cooler air from underneath could seep into the church and keep it cooler, which is what it does. But it, of course, then takes the radon into the church as well. Okay, if there's anybody interested in caves, and I know there is at least one in the room, we also measured radon in the Kango Caves, which is a show cave near Oudtshoorn, which is about 400 or 500 kilometers from Cape Town. The levels, again, weren't that interesting, but it was certainly fun to go and explore the cave and run in and out and measure various things in the cave. Okay, then getting back to mines, this is a totally different mine. This has nothing to do with the gold mines, but this is a mine called Steenkampskraal, which is an old Dutch name, which is about 300 kilometers north of Cape Town. And the student who's here with me, Nkosi and Gwadla, we and two of us and three other students went to the mine a few months ago. This is an old thorium mine. And what you see there is fairly new things which have been put up because they want to start up this mine again. It was used from about 1950 to 1962, where they extracted thorium in the early days when people were interested in perhaps having thorium reactors. And then it shut down. But there's very big interest in opening it up again, not because of the thorium, but because it also has rare earths like neodymium and various other rare earths, which are now needed for the battery industry and magnets and things like that. So it may well be opened up again. But what is amazing about this mine is the levels of thorium in the mine is the mine owners claim, but maybe that's because they're trying to sell it. It's the highest grade of thorium in the world. There are lots of high thorium areas in places like India as well, but this is pretty amazing. So this is what this mine works. That's the steps you have to walk down. It's got no elevator, but it's not very deep. It's about 100 meters deep. And you don't start right at the top. So we had to walk down about 50 300 steps, something like that. So we go down, put the detectors down, walk up again for coffee, walk down again, and got pretty tired by the end of the day. Here's a picture of one of the mine owners that I got off their website. It wasn't one of us there. As you can see, there was no electricity when we were there downstairs. Here, there was specially lights brought in for the day for the advert. Okay, that's what it looks like around the mine. Very, very dry area, part of South Africa with sheep farming and not much else. On the right, I don't have many pictures from underground because, as I say, there's no lighting underground. So that's our RAD7 detector sitting there with a small tube with dry light sucking in the air from close to the wall, where they told us there's a seam of monazite. And the values we got, even though we went right next to the rock and so on, the values we got were absolutely amazingly high. Before I get, while I've got some pictures, on the right-hand side, there shows what another part of the mine from the outside. So as I say, it's only about 200-300 meters deep maximum. And there are 3 different levels. And it all looks a little old and jagged, and there are other holes and whatever. So some of the thoron does come out, but the thoron levels are still high. On the left-hand side there, this is in the mine. There are copper sulfate crystals forming as water is seeping somewhere at times. Generally, it's extremely dry. I don't know if there's enough copper to start a mine like in Sudbury. I doubt it. Otherwise, somebody would have about it by now. Okay, just if we've now got our measurements there, and we've got a paper which is going to be published. It's already available online in the Health Physics Journal, where we spoke about the radiation protection issues there. The thoron levels are above where we measured next to the seam, above 10,000 becquerels per cubic meter. There's a minus sign missing in the 3 there. I guess I had a slash initially. Sorry, becquerels per cubic meter, of course. 10,000, that is huge. What is interesting, though, is about 5 meters away, we measured as well. So this is just 5 meters away from the level, this high level. The value was less than half of that, which, of course, at first you think, oh, how can that be? But of course, thoron has a half-life of less than a minute, and there was not much airflow. However, what was nice about this mine is we could do an experiment where they switched on the ventilation. They've put in some ventilation just to check how things, whether the ventilation would help with getting rid of the radon and thoron. There's fairly high radon as well. And so they have a ventilation system. So we had an amazing opportunity to do some experiments. So we could measure, we could then pump and put on the ventilation and see what would happen. And that's part of the stuff which is published in the paper there. What we discovered, as I said, the exact value depends very much on the position. We also measured the exhalation of the rocks, and we could then measure with ventilation on and off. Here's some of the data. The radon measurements were not so good because we measured for 5 minutes at a time. We didn't have long measurements because we had to measure the thoron, but the levels were so high. In 5 minutes, you would get enough statistics to get reasonable values. Okay, so time runs along the bottom. This was, and the radon levels are given. Before the ventilation was started, the radon levels was about 300 with quite a big error bar. Mouse again, there we are. The ventilation was switched on where the red line is. So here it was about 300. Then we switched it on and it got very low. It was sort of consistent with 0, if you like. Then we stopped the ventilation and then it went back up to this sort of level. And then it went even higher. And to be honest, I don't know why. I can think of various things of how radon was moved around or whatever, but that's entirely clear to me. That's the radon. The thoron levels started off, as I say, at 10,000, and then we started ventilating. Again, the arrow is the period during the ventilation was on, and it dropped down immediately down to about 5,000, and then it went up again, levels of even higher again. I guess the way we disturbed the air must have got air sucked out of areas where the values were even higher. Okay, so we were happy it's down to 5,000, but then down to 5,000, we were within 200 meters of the entrance. The fan is sucking in air from the outside, and it's fresh air. Why aren't we getting lower values? And I have to admit, I thought about that for a while. I mean, the values are much lower, so we're getting in fresh air and it's mixing and so on. But again, with thoron and radon, you always have to think of the details. You have to think of the exact decay chain, see what is happening. And when you think about it, again, I've sort of given you the answer. The half-life is only a minute. So I tried to make a drawing here, but it's not very good. So this is roughly what we've got. We've got a fan sucking in air from the outside, going through this tunnel and going out again. And we were measuring of the order of, I think it was actually a little less, 500 meters from the entrance. So if I had a bunch of students, I would now ask them to try and explain what was happening. But since it's a talk, I will tell you. So we were measuring at this X there, and the wind speed was about 3 meters per second. So if you think 3 meters per second and the half-life is around a minute, 6 times 3 is 180 meters. So, or if you take the average life, it's a little longer. But so we were not actually measuring the fresh air that's coming in. We are measuring what's happening in this whole region before the cross. So we are measuring in this region, and if I've now made a red dot saying that's about 180 meters away from the black cross. So actually, we're not measuring the outside air, we're measuring the air in that region, because that's the air which is moving past us, or the ones that decay is the thoron, which will be all of the thoron in that region. A lot of it could be decaying where we are. So in this mine, even though it's so shallow, ventilation is not going to pump out the thoron. The thoron is going to stay there. Is this a big issue? Well, I had a problem in writing the paper because I've got to keep the mine owners happy as well. And if I told them there's a huge thoron problem, you can't open this mine, they will be very unhappy. However, well, I had to ask permission from them to publish the paper, of course, because they're quite sensitive about details. But they were happy because I then said in the paper, which is possibly true, probably true, but I haven't proved it yet. What I told them is, yes, no, what I said in the paper was that it's not such a problem because, of course, the lung cancer is not caused by the thoron, it's caused by the daughters. And the first, thoron decays to polonium-216, and that has a very, very short half-life. So that is unlikely to stick to dust and get into your lung. The important one is lead-212, and that has a 10-hour half-life. So in this mine, the ventilation may well be good enough to pump out all the lead-212. Did I say it correctly? Yes, lead-212 has a half-life of hours. And in this sort of setup, if that is the setup, we may well be pumping out a lot of the daughters. So to be able to do a full radiation protection study of this place, one would have to go and measure the daughters and not just and not the thoron. In many mines, of course, people measure the radon, assume some sort of equilibrium factor, and then they say, well, that's the working level month which these miners are exposed to, all these units. Okay, so this mine was used in the 1960s, and I implied in the paper that at that time, people didn't really study this very much. There was problems with radon wasn't that well known. I mean, the mine work study in the US, or the uranium miners in Colorado and in Europe, which is the sort of basis for showing that high radon leads to lung cancer, that was only done in the 1950s. So this is way down in South Africa. People didn't know about radon. That's what I thought. But sometimes history tells us too that one assumes too much. I found a reference to an article or a presentation which the South African made at an IAEA conference, but I couldn't get hold of the paper. So I referred to it, but I didn't give any of the detail. And then subsequent to actually submitting the paper a few months ago, I actually got a copy of it. It was a paper written by a guy, so don't always think that the old guys didn't understand it. It was a paper written by this South African physicist who was linked to the Department of Mines, experience in the control of radiation at a small thorium mine in South Africa. and his initials were RSJ, and his surname is he's a French Huguenot surname, Dutoit. Though in South Africa, because we don't speak French, that surname is now pronounced as Dutoit, but that's a sort of a Dutch way of pronouncing a French surname, which is often very funny to some of the French people. Anyhow, so this guy actually did an interesting study, which must have been around, the conference was in 1963. By then the mine had already shut down. And reading the article, he clearly had done quite a few measurements, and he said to the owners, you guys had better do something about this. And they did. They changed. They were then using cleaning the overalls which we're using and doing things like that. The paper is quite interesting. There were a number of things which I didn't understand, and there were some interesting units used. I had to think about this. Well, and I'm not sure what he means. It says 8 micro C/L. I assume micro, that means 10 to the minus 6 times 10 to the minus 6, which would be 10 to the minus 12, which we would now call pico. And the C is a small c, but I'm assuming that's curie. So I'm assuming he means 8 picocuries per liter, which is actually much lower than what I measured, but in parts of the mine, that might be the level. It's not clear from his description of exactly how he measured it, but it was kind of fun to find an old paper like this showing that some people, even in those days, were doing some useful things. And that's more or less my story. So that, plus working with my colleague Smarajit Triambak, who spoke to Giorgio, who said, why don't you guys get involved in nEXO? Because Smarajit was doing some experiments linked to the matrix elements that are needed for xenon. That's how he and Smarajit and Giorgio ended up at the same conference. And then when Smarajit mentioned it to me, I said, no, but I'm not really involved in particle physics anymore. And he said, yeah, but radon is an important thing. And here I am at Snow Lab talking to Jacques Farine and talking about having some radon measurements done in South Africa as well. Okay, thank you very much. That's my story. Just one more slide. Please come and visit us in Cape Town. It's one of the nice places in the world. There's the beach with my daughter and grandson with Table Mountain in the background. Thank you very much.
Thank you very much, Robbie. Please accept a semi-virtual round of applause. I'm sure people in the room.
I would just like to apologize to the people in the room. I always get taught, look at your audience, but somehow, because I have to look at the screen, this was totally impossible. And of course, I was really worried that if I looked at the audience, you wouldn't be able to hear me because I wouldn't be speaking towards the microphone.
Yeah, I appreciate the adjustment on a new hybrid era. Thanks again for the very comprehensive seminar. So let's open the floor for questions or comments for Robbie, if there's any. Please feel free to raise your hand and I can call you up.
I don't think this is the kind of talk which will raise too many questions, I hope. I mean, it should have been clear.
Anything from the room, maybe? We don't have any questions coming in from Zoom.
I realized that you should have a double shower before you enter the lab. You carried any of this ore with you. That's too much story we want to have.
Yes, I think that Jacques is absolutely right. I mean, I was thinking after seeing his lab yesterday that we really need to have some sort of clean lab at UWC as well. And the one obvious place is the room where at the moment we are storing some of these rocks. So to clean that room, we would probably have to sandblast the whole room before we could possibly think of using that as a clean room.
Art, please go ahead.
I see a question from Art McDonald.
Yes, indeed. Very interesting talk. Have you talked at all with people there in Sudbury about the coatings that are on the walls, particularly in the cavity where snow is located, which have very low permeability for things like radon and thoron?
Okay.
They were developed originally by mining engineers to protect uranium miners in Canada. in the situation where what they wanted to do was to put these coatings on the walls and then prevent the radon from coming out of the wall, so they could circulate fresh air in the way that you're doing. Obviously, you're in, particularly with Doug Hallman in the vicinity, who is the expert on those coatings. It might be interesting for you to discuss it, because it's one way to mediate the problems you're having.
Yes, thank you very much for that question. It's a very relevant question. I didn't mention that, but I am also involved in a research project at the moment where the National Nuclear Regulator in South Africa has said that